do appreciate all y'all coming, though. It's this is been in a planning stage for a while. Dr. Frank Harrell's kind of put this package together. He's our programming director for the club, and he's done real good getting some top shelf people to come in here and give us some programs. Yeah, he's done real good with that. Matter of fact, I think it'd be a good time for me to turn it over to Dr. Frank and get this program started.
Thanks, Mike. It's a real pleasure. I did not realize that he was from Mississippi and that he got his bachelor's degree from Mississippi State in electrical engineering until I happened on a YouTube video of the Tapper Conference, and the MC introduced him as being from Ole Miss. And he politely corrected him. He was from Mississippi State. So I was delighted to learn that Gerald is from Mississippi State. And then when I heard him talk about himself a little bit, I realized I knew a fair amount about him. He was a principal in the Sun River Corporation, which was a chip designer and some other circuit boards and some things like that. Certainly a high-tech entrepreneur here in Jackson, and was lured away to Texas and the Silicon Hills, as the concept I think was when they were doing their everybody wants to be another Research Triangle Park from North Carolina and that kind of thing. And Gerald has become eminently successful. Now, I think WLBT will correct some of the lenses that cracked today at lunch when at least one of us was on camera. But Gerald and I did a WLBT midday show today to kind of introduce him to the Jackson area audience and just kind of let them know that here's a local boy who's gone out and done really, really well. And so Gerald got his bachelor's degree in EE at Mississippi State and has gone on to a career helping launch Channel 16 here, installing their equipment, having been an engineer at WJDX and
WZZQ at the time.
WZZQ at the time. And so he had quite a career here in Mississippi before moving to Texas. So we're real proud of the fact that he's here visiting family and was willing to stay over a day. He's brought some of his wares, and I think if you're not using SDR, you're going to learn a good bit about that. So without further ado, would you give us a good CMSARA welcome to Gerald Youngblood?
Thank you very much. Well, thank you for that introduction. Let me get a few things out of my way here. Welcome from the Republic of Texas. So I am a Mississippian. I was born and raised in Mississippi. Lived in Pachuta, Scuba, Sumrall, Bolton, Wesson, and then Laurel for a little bit, and then Stark Patch, the university. They call it Stark Vegas now. Is that what they call it up there now? They changed that. It wasn't called that when I was in school there. So I'm definitely a Mississippian. My accent comes back some when I come here, so I'll try to speak with the right accent. It's really fun to be with you, and I hope you'll enjoy it. I only saw a couple of hands with SDRs. We can fix that tonight. We can definitely fix that. So what I'm going to do tonight is I'd like to tell you a little bit about my journey into ham radio and electrical engineering and my career, how I got here, and how some of the things in Mississippi play a part of that as well. And I'd also like to talk about how I accidentally started Flex Radio. I didn't set out to do it. I've started a number of high-tech companies in my career. I've spent most of my career starting and running and raising financing for companies, but this is one I didn't set out to start until I just kind of accidentally started it. And it's in something I love, ham radio. Not many times do you get to actually have a career in your hobby. Now the problem when you have a career in your hobby is that you don't go home and do it anymore. You know, you kind of do it all day, and so you don't. So it does kind of trade off there. But what I'd like to do is talk just a little bit about. You know, Yogi Berra said, when you come to a fork in the road, take it. And that's the story of my life. And that's true in both business and in life. There are inflection points. Andrew Grove of Intel said in his book, Only the Paranoid Survive, is that businesses have inflection points. These are critical points in time when everything is going to change. If you don't do anything, it's going to change. If you do something, it's going to change. It's either going to die quickly, die slowly, or it's going to grow. Those are inflection points. Same thing is true in my life. I would say one of those inflection points was ham radio. Getting into ham radio was an inflection point. Meeting my wife was of 40 years. It was a huge inflection point. So there are lots of inflection points, both business and personal, and those interact in our lives, don't they? Those things, we can see them coming together. So I'm going to talk about how ham radio has affected my life. This is me as a teenager. I don't know about you, but and I'm going to tell you a little bit about the story about how I got interested in ham radio. It begins with discovery of radio. I was living in Scuba, Mississippi, I think it was. No, wait a minute. No, I was living in Wesson. No, let me get this straight. Wesson's south of here. It's been a long time. I think I was living in Scuba at the time. That's where I was living. Everybody know where Scuba is? Yeah, Scuba. So, yeah, I see a hand back here. So, I was given a World War II transceiver. I don't know what it came out of, but it was about this big. I remember it. And it had hundreds and hundreds of electronic parts in it. I had no clue what those parts were, but I can tell you I was fascinated from the moment I saw it. So I didn't have anything but my dad's pliers and, you know, some scissors and stuff, and I cut every part out of that. And I sorted them, and I put them into these boxes. Now, I took this picture in the last year. I still have those boxes in my attic, and they still have some of the original parts in those boxes that I cut out of that World War II transceiver. And so I got an Allied catalog, and y'all remember Allied catalogs, and I would go through that catalog, and I'd say, oh, that's a resistor. That's a coil. That's a, you know, and I'd go through it, and I would figure out what those parts were, and I sorted them into bins. I didn't know how to use them, but I sorted them into bins. One of my friends got his ham license, and I remember he had a big old Hammerlin HQ something. You guys might know. 180. Yeah, something like that. And I thought that was the most beautiful piece of equipment I ever saw. And I think he had a Heathkit transmitter, and he'd gotten his novice license. And so I was in the 9th grade at the time, and I was really fascinated by it. But I didn't get my license. We moved to Wesson the next year. Wesson has Lincoln Junior College. And I found my Elmer, Don Johnson. He was a physics teacher at Lincoln Junior College, and the high school was on the campus. And so he helped me build my first 6L6 transmitter. And so I had a Hallicrafters S38 receiver. Some of y'all remember those. They were broad as the side of the barn, receiver-wise. So anyway, that's kind of how I got into it, and I was just fascinated with the technology. Both, how can you magically put in signals into the air on a wire and then send them around the world and then collect those signals and be able to hear it? That's magic. By the way, it's still magic, and I now design transceivers. I now design radios, and it's still magic that we can do that. I'm sorry that more younger people don't appreciate that magic that we have today. I tell people about half the people don't know what ham radio is when you tell them. And so when I have to describe it, I say, well, it's the original electronic social media. That's true. We are the first social media 100 years ago, electronic, and we were sending digital before the word digital existing, right? So CW is digital, owns it ones and zeros. So that's the way I kind of start, and then I say, well, why would you use this instead of a cell phone? And I said, well, a cell phone, have you ever fished in a stock catfish pond and then gone fishing in the Rockies with a fly rod? one's sport, the other one's not. And so that's the way I try to explain ham radio today. But anyway, those boxes, which I still have, were what got my start, and my friend in the 9th grade and Don Johnson helped me get a start. And from that, I went from making C's to making A's. And I got interested in becoming an electrical engineer because of ham radio. And I started applying myself. And my mom was glad about that. So I said, I want to go to Mississippi State. I want to be an engineer. I said I would never get in sales, by the way. Don't ever say never, because you're always in sales. So anyway, I went to State, and so I had to have the bulldog in there. Too bad about this weekend. Sorry if you... So at the time I went to State, there was a guy who's a ham there in Wesson who had gotten the chief engineering job to help build WAPT, Channel 16. And so he said, would you like to co-op with Channel 16? So I got a job co-oping my junior year at Mississippi State. And so we were building Channel 16 it was mud out there and just a foundation when I started working there. So I worked there a few years, and then I got a job with WJDX, WZZQ. I saw some heads nod on ZZQ, right? Album Rock, right? Some of you recognize that. It's amazing what you can find on the internet. I dug that up today to get it off the internet. So those were my early jobs, and then I started a PC board manufacturing company in 1975, which burned down about a year later, and then I went to work for Diversified Technology. I don't know if any of you have heard of Diversified here in Jackson, but I worked there for 9.5 years, and then 3 of my coworkers and I decided we wanted to go start a company. And so we left Diversified in 1985 or 6, somewhere in there, 85 I think it was, and started a company called Sun River, and financed it with a local investor, invested in the company, and then in 1989 we were trying to raise venture capital, and so we visited Silicon Valley and all the different venture firms, and they said, we'll invest in you, but not if you're in Mississippi. And so that was a tough one for us because we were all Mississippi boys and we wanted to stay here. In fact, we even had Governor Mabus, was governor at the time, actually call the venture capitalists for us trying to keep us here. And they took the call, but they just said no. So we moved to Austin. That was in 1989, moved to Austin 26 years ago and have been there since. Now, I will say, Austin is a technology city. Austin has probably doubled in size in the time we've been there. There are now almost 2 million people there. And the traffic shows it. But anyway, there are lots of high-tech companies. Apple's put in 5,000 employees in this last year, built a huge facility. So it's really a high-tech center. So it's actually been a good move for us. We miss Mississippi, but in high-tech, it was the right thing for us. So anyway, you'll see the Wolf Tales Co-Ed Junior College. One of the things is we built a radio station on the campus from scratch. Begged, borrowed, and stole and did a radio station there. That was kind of part of the transitions along the way. Sun River became Boundless Technologies. We took it public in 1994. And so grew it to a sizable company of about 500 employees. And I left there in 96 and then got involved in the venture capital area. Let's see the little seed stage over there, the little web page of seed stage where we would help startups go from to raise their first major round of venture funding. And so I was involved in that until the dot-com bust. If you remember, that was about 2001. And that plays into the story. All of these things are part of the story. Now, I'm sure any of you who were hams as a youngster, and then you got married, had kids, career, all those kind of things, life happens. And so for me, ham radio became secondary for a lot of years. And I still loved it, kept my license, had my SB 301, 401 sitting in the corner, but didn't do any much with it. And so during that time, I built a career. But back about, I don't know, maybe 14 years ago, something like that, my son and I heard about in Austin, there was going to be Field Day, 1997. And my son, I think he was, let's see, must have been, he's 30 now, so whatever that is. I can't do the math. So he said, Dad, I'd like to go field, let's go do that. So I took him there, and he came back and he said, well, I'd like to get my license. Would you help me study for it? And man, as a dad who's a ham, you can't ask for a cooler thing than your son saying, would you study, help me study? So he got his license, got a novice license with a 5-word a minute back then. And he said, well, Dad, you ought to take your extra. I had an advanced. And so I took my extra and passed it. And that was my re-entry into the hobby. So there was an inflection point. So I just dug in. I actually had a little more time on my hands at this point. And so I started playing, just getting back into it. A lot had changed. And one of the things that had changed is now you had PSK31. How many of you operate PSK31 in the room? Good number of you, and you know what it is. It's basically electronic social media on the keyboard. It's just like texting over RF. My first contact was over the pole to the Ukraine, and it was fairly audible signal, and I said, that's really cool. You can actually take a PC and run your radio into the sound card and detect signals. And by the way, that's signal processing is what you're doing in the computer. I said, I remembered a class I had my senior year, and I said, I bet I could take in-phase and quadrature. I don't know if any of you remember phasing transmitters, phasing receivers. How many of you remember phasing transmitters? Central Electronics 20A was my phasing exciter when I was a teenager. That's a phasing transmitter. That technology has been around for almost 100 years that you do it. Well, guess what? That's the same technology you use in your cell phone. It's called in-phase and quadrature. You learn the math in middle school. Pythagorean theorem is the core of math of how these things work. And so I said, I bet I could take a sound card and put in-phase and quadrature into the stereo inputs and build a radio around that using the PC as the computing engine to do that. I decided that in 1999. I hadn't done any engineering, by the way, in since about 78 was the last engineering I had done. So 1999 is a long time in between engineering. So I didn't know how to do engineering anymore. In fact, I never learned the stuff that I needed to do this, but the internet had come along. And suddenly you could learn just about anything on the internet. And so that opened up my world to be able to go back and learn the engineering skills that I needed to build a radio. So this was purely a hobby that was kind of built around that. I think I can build a radio taking a PC and a sound card and this in-phase and quadrature and a lot of work, and I should be able to build a radio. Well, that was 99. And so I started playing around with something called a quadrature sampling detector. This was my first prototype of the SDR 1000, which was a detector. And here's my second prototype. And here's my third prototype. And then here is what actually was, you might really call it my fourth prototype, but it actually went into production, the SDR 1000. It actually started shipping in March of 2003. And I'll show you in I think I have a picture in a minute. I had to write some software. So I learned Visual Basic and had an hour of Fortran in college. And that was all the programming I had. So I learned Visual Basic, which is kind of similar to Fortran. And I wrote software, and I had to learn digital signal processing and how to do graphical user interface work and all those kind of things, but how to talk to a sound card and all those things. And it was pretty hard. It took me 4 years of hard work. I went into almost a cave. I'm glad my wife stuck with me during that time. But it was so hard for me to do, and so much of the material was written for mathematicians, and I had forgotten more than I ever knew about math. So I wrote a series of articles for QEX, which is published by the ARRL. It's the technical journal. Kind of replaced ham radio, if you remember. Anybody ever take ham radio magazine back in the old days? Some of you back there. That was one of my favorite magazines. Anyway, I wrote a series of articles, and the first 3 I wrote in 2002, this was purely a hobby. I had no intention of a business. I was just trying to write about my experience on that. And these articles are available from our website and on the ARRL as well. And it's called A Software-Defined Radio for the Masses. I wanted to do one of the for dummies, but that was already taken, unfortunately. And then there's another thing happened before I wrote the last article, is that this is the plot of the NASDAQ. And you'll see where I started the hobby, and I was actually involved in seedstage.com, which was in the venture capital kind of area, and we were helping all these companies these .com companies get funded right here. Well, they were easy to get funded. We got a dozen companies funded in 18 months, typically $2 to $5 million per company. So it was going like crazy, okay? And I was playing around with this hobby on the side while this thing was going up. Well, here's what happened. The other side of that thing fell off. And so I'm not going to go into the details of what some of these things were, but about right here, I was writing those articles. And all of those companies that I had gotten funded, guess what? The venture capital just dried up like the desert. Nobody was funding anything during that time. So I had started companies all my life, and so I'd been playing around with this radio thing, and I actually had something working, and it sounded really good, and you could see the signals as well as hear them, and I said, well, maybe I'll start another company. But I've had it with venture capitalists. I don't want any investors. They're overhead. I just had it. I don't want to do that. I've got a closet full of those T-shirts, I promise you, from all those companies. And so I said, I'm going to bootstrap the company. I had hundreds of emails from the articles that people had written me all over the world, and they were saying, boy, this is interesting. I've kind of lost interest in the hobby, but this is really getting me back, my juice is flowing. Can you build a kit? That was kind of where it started, and I said maybe. And so in the 4th article I said I might have a kit. So I decided I would build 10 of those SDR1000s, and I was going to send an email out, and I said, I'm only going to build 10 because I know how hard it is to support people. You have to tell me what your resume is to get one, because I want to know that you really are into this and you know what you're doing. I don't want to deal with, you know what I'm talking. I'm talking about early adopters, because I didn't have much stuff. It was just glued together. The software was sort of there, and I knew it needed a lot of work. I got 50 orders from that first email, 500 orders from March through the end of the year. We were boxing those things, and my kids would come home from college and kit parts, and we were boxing up in the living room and shipping them out the front door to UPS, the UPS truck coming up to our front door. So that was the way things started. So I said, maybe there's a business here. That was kind of 2003. So I took my office/ham shack and turned it into a development office, and bought some old test equipment. We were talking about oscilloscopes over dinner tonight. You probably recognize that one. So this was doing development, and the coding happened right there. My son-in-law my oldest daughter got married in 2001. My son-in-law was at University of Texas in computer engineering. The engineering market was drying up at that point, by the way, along with the dot-com bust, and he was looking for a job, and I was killing myself, and I said, I need a software engineer. We'll try it 6 months, and if we still like each other after 6 months, we'll agree to go forward. I didn't want, dealing with family is not always a good idea. He's still there today. He's still with the company today. He's a senior software engineer, vice president of the company, and that was his letter jacket back then. Now, and he was doing software. You notice that phone right there? See what it says? Joe Walsh of the Eagles called here. He bought a 1,000 and then he bought a 5,000 and he called up for support and he said, "Hello, this is Joe Walsh." And I said, "Who?" And so I handed the phone to Eric and let him do the support, but that's a true story. And so here's K5CAT helping out. I mean, it was in the home, That's Charlie the cat. Now, interestingly enough, in ham radio, you end up with low friends and high places. You ever heard of that term, low friends and high places? Well, this is a low friend and a high place. It turns out that he worked for the National Security Agency, and he's a ham, N4HY. And he was plucked out. He grew up in Alabama, went to Auburn, and they recruited him to put him through Princeton. He's a mathematician, but he's a ham and one of the nicest guys you'll meet. He called me up and I didn't know who he was. Well, first thing I heard, he wrote a letter to the editor of QEX criticizing the software I'd done. Telling me all the things I'd done wrong in it. So I did remember that. And he called me up and he said, "Hello, this is Bob." I say, "Bob who? There are a lot of Bobs on Earth." But anyway, he'd do that a few times and he said, "I want to rewrite your software." He didn't like my software. By the way, I didn't give him one of the first boards. He was one of the first orders. I held off for a while because I didn't like his criticism. So he said, "I want to rewrite your software and I want to get the government to fund it over open source," which had never been done before. So actually he did accomplish that. He got it set up so that he and Eric were texting. He was inside the NSA, approved to text and write open source software, and they were writing it together for Power SDR. He wrote the digital signal processing code, rewrote all the code that I had done and replaced it with new code and wrote that, funded by the government. They got the rights to it, and it was used in other things that I don't really know what they are, but we got to use that code, and that became part of what's now Power SDR. So and Bob we became good personal friends. He spent many, many weeks at my house. So he would come down, being paid by the government, stay at my house and write DSP code. So that's the cool thing about ham radio, low friends and high places. In fact, I learned that term from him. So we announced the product in 2003, and then 2004, actually we're in the Tapper booth, 2003 at Dayton, and then had the first 10 by 10 booth, and we actually still have that slot, only we've expanded it to 20 by 35 feet now from that little 10 by 10 booth, but that's what it looked like back then. And then so really it started out with that 3-board set I showed you earlier, and then we added a Dagwood sandwich in the middle to actually improve the performance. And amazingly, this radio turned out to be one of the highest performing radios at the time, in terms of dynamic range and low distortion. And that was just amazing how well it worked. And so a friend of mine on the ham radio breakfast said, "Well, I'll design an enclosure for you." So he designed the enclosure. That was over breakfast. So a lot of this got designed over breakfast. I had a mentor who was an engineer, and I would ask him questions. He'd tell me how dumb I am. And that was kind of how the SDR 1000 got built. And so, but over time, from 2003 and about 2006, I think we built close to 2,000 of those, which is a pretty good number for what I call a prototype. Got a lot of them out there, mostly to early adopters, people who are experimenters, early adopters, and these things are still in operation today. We still repair them today. But you basically had to have a lot of wires. Sound card. You had to have an external sound card that plugged into the radio, and you have ground loops and all this stuff, and you had to make all that stuff work with drivers. So it was an interesting thing to make it all work. And so we said, we got to do something. And I don't know how many of you ever heard of the technology adoption curve, which is a bell curve, is that the technologists, the enthusiasts are over here, the visionaries are here, and there's a chasm before you get to people that are pragmatists. They just want to turn on and play radio. That's the people over here. The people over there will buy the newest thing. They don't care if it's put together with glue and baling wire, right? So we had to get across that curve. So how do we do that? Well, we conceived of something that became the Flex 5000. That's a cake that made by one of our customers. I think his wife made it for him, and he gave it to me, and I thought that was really cool because you'll see the 5000 on the left and Power SDR on the right. And that's the kind of enthusiast we've had over these years. But that was conceived, and it was designed in that room that I showed you earlier. You can see the prototypes over on the right. So there was a huge jump between the 1000 and the 5000 because we integrated all the sound card and everything in and went to FireWire as the communications with the PC. That was getting rid of all those audio in and out and all the ground loops and mess that goes with that, and just putting it inside the radio itself. And this was a typical week of things that we had to do that week, and software and hardware and all that stuff. And it drove Eric to drink. That's literally his Longhorn jug there. It's a 1-gallon jug, and he drinks water out of it. I just thought that was funny. And then we started showing off our baby. By the way, we announced the product, and everybody quit buying the 1000. Think about that for a minute. But we had to kind of announce it because we took pre-orders, and so we got pre-orders, but they quit buying the 1000. It always takes longer to develop than you think, too, by the way, if any of you know that. So Power SDR, that became an evolving product, and because it was open source, other people started to adopt it. You probably heard of SoftRock. You ever heard of that? He was one of our customers and grew out of our user group. HPSDR grew out of the Flex Radio user group, if any of you have heard of HPSDR. And so we were developing this open source software and paying developers to do it. We're the only people paying developers to do it. Over the years, the 5000 came out in 2007, the 3000 in 2009, and then the 1500 in 2010. The 1500 is still in production. The other two are no longer in production. I'll show you what's replaced those. Now, that low friend and a high place, interestingly enough, we were sent a request for quote to build a radio system that became these two things on the top right here, SERX and CDRX. We bid on that system and won that system, and really the thing you see on the right is 32 Flex 5000 in a 7U rack that are synchronous. All of the receivers are synchronous. They tune synchronously. And so you can take all these antennas in and precisely know the angle at which they come from and the time of arrival and all those kinds of things. So it's a very interesting kind of system, but it has an Ethernet connector on it. So all of these signals are being streamed over an Ethernet connector. This is important as I start to talk about what we're doing today. And The little board on the left is a PCI Express card that has a direct sampling receiver, and I'll show you what that means in a minute. And it had 16 receivers on that one card. And it could simultaneously look at all of HF, and the spectrum of all of HF, and detect signals and then steer receivers to go to those frequencies. That's what those were. That was one contract. We did that in 2008, and I hired our VP of Engineering, which was a key, Steve Hicks, who really became a key player in our architectures for the future through that contract. Then we got another contract in 2011. That's a 1U rack that has 24 L-band receivers in it and 4 10 gigabit Ethernet ports. We can fill those 10 gigabit Ethernet ports. So that's a satellite receiver. It receives on the satellite bands. So those, and that gave us a tremendous step up in technology of what we could actually build for ham radio. We actually used ham radio to leverage it into what you see at the top, and then we take that back into ham radio. And that's what I want to show you is how that came back. Now, some of the problems that we were having in support with the FireWire systems is we have driver issues with Windows. I don't know if you've ever dealt with driver issues with Windows. Believe it or not, at the time we started with FireWire, it was the leading technology for streaming, audio and video. It was designed to do that. USB was not designed to do that, unfortunately. It's a very different protocol system. But FireWire started getting hard to get. A problem for us. We had problems making CW work well because we used the PC as a fat client, or all the computing was done on the PC, and the radio was just a modem. You can think of it as a modem. And we had to get back and forth and make CW happen. CW is the hardest mode to make happen, believe it or not, well, especially for your QSK. You want to do real-time QSK, it's a real-time system. And so it's actually a very difficult thing to do. Sideband is easy, believe it or not. CW is hard to make. Now, it's easy to do on a 6L6, but you can make it chirp really well, you know. So, and then we had, because the software had kind of evolved over time, it became what we call spaghetti code. You pull one piece here and it comes out over here, you know, and so it's whack-a-mole. And really the state of the world was changing. The internet's changing everything. The Internet of Things, Ethernet, is ubiquitous. You can't buy a PC that won't do Ethernet well, the internet well. They have to do it well. So we looked at that and we said there's another inflection point. Let's take a clean sheet of paper and start from scratch. I don't know if you know how crazy that is to say we're going to abandon, we're going to start over, we're going to start with no hardware, no software, we're going to abandon open source, because we were actually paying engineers to write software for competitors in a small market. Ham radio is a small market, by the way. And we said that doesn't make a lot of sense. And also, how do we really make it something that can build for the future? Can we leverage what we learned in doing the government and commercial systems into ham radio? Bring that in, really raise the bar in ham radio. That's what we wanted to do. So we started on that in June of 2011. Now, I'm going to take a little detour here and then come back to what happened there, because I want to explain a little bit about architectures. A superheterodyne was invented in 1918. Do you know that's still what the majority of the other radios are today? They're still superhets. They're multi-conversion superhets. They might be triple conversion or double conversion, but they're the same technology was invented in 1918. However, back in the 80s, they started putting DSPs on them, right? Okay, so that has some signal processing on it, but it's limited, because what we do is, let's say the RF spectrum we're looking at, they might take it up to 64 megahertz and bring it back to 455 kilohertz, and then bring it down to 38 kilohertz, where the DSP, the A to D and DSP, can deal with it somewhat in the super audio range. That's how those kinds of radios work. That's ICOM, Kenwood, Yaesu, Elecraft, Tintac. All of those radios are in that class. Now, What's wrong with that? Well, every stage that's analog adds distortion and noise, every single stage. So if we have 3 stages, you're adding 3 stages of distortion and noise. And we're going to sample at 96 kilobits per second is the way those systems work, and then we're going to process it in DSP, okay? Now, direct conversion has been around, I can't remember if it was before or after superhets, but it's been around. Direct conversion receivers have been around a long time. I mentioned that my Central Electronics 20A was a direct up conversion. It's a direct up conversion exciter. So that technology has been around since before World War II. However, the technology had improved to the point that we could do it with very high performance. And because we have signal processing, we can fix the problem between in-phase and imbalance between analog systems. Some of you may know and some may not what I'm talking about. So the SDR 1000, the Flex 5000, 3000, and 1500 are all direct conversion receivers. What I mean by that is we come from RF down to wideband audio in one step. You could do that all with analog, and you could listen to it, and you can hear the phase difference between, it sounds like being stereo if you listen to that kind of system with no processing on it. Have you ever listened to binaural audio? That's what it sounds like. It's kind of a stereo sound effect if you don't process it. Well, that's how those radios are done, and we sampled those radios at up to 192 kilosamples, so we could actually see 192 kilohertz of spectrum on the pan adapter with very high resolution. And so we started kind of setting the standards for real-time high-resolution spectrum displays where you could point and shoot at a signal. That's kind of a different way of looking at radio, visual radio, instead of just twiddling and trying to find a station. So now the holy grail of SDR, now what's SDR? Anybody want to define SDR for me? Tell me what SDR is. Somebody want to do that? For a mug. Yeah, so what's a true software, what?
It's got to be in the IM.
So what's a true SDR? Somebody got to get that. It could be digital audio. Anybody know? Oh, somebody needs this mug. Am I have to tell you? Okay, I'll tell you. I'll give you some more ways to get. I got mugs and hats. I got to give them away. I can't take them back. So software-defined radio is where 100% of the modulation, demodulation, filtering, mixing, everything is in software, and therefore you can modify it. You can change it very easily. Either the manufacturer can change it, we can download it into the radio. Now, there are some people that are saying their DSP radios, the superhet DSP radios, are that same thing. My battery's going dead over here. I'll have to grab another battery. There are people saying that you can stick a DSP on the back of the radio, but you can't do 100% of that. What if you could directly get the entire RF spectrum, run it into an analog to digital converter, and you're processing numbers. And I could take those signals and mathematically manipulate those signals. In other words, right at the antenna, I digitize the signals at the antenna and use very high-speed processing to take those signals and filter them, demodulate them, and put them down in the audio spectrum. That's a software-defined radio, and that's the optimal way for that to occur. So that's what we set out to do. To get back to this, in our newest radios, we sample the antenna at 245 5.76 million samples per second. In other words, think of it as like a voltmeter that I'm going to sample that many times a second, a digital voltmeter, and I've got numbers now. And with those numbers, the same math that works in the analog world works in the digital world. I can build filters in math. I can build perfect filters in math, ones that don't ring. I can have 10 hertz bandwidth filters that don't ring. Try that with a crystal filter. Have you ever listened to ringing in narrow crystal filters? Digital filters don't have that distortion because they're perfect. And I can make near perfect mixers, all of those kinds of things, and I can get rid of all that distortion. And if I take in this whole bandwidth, I can look at all of HF at once. In fact, I can look for DC through 70 megahertz at once. And then I can go slice that up into receivers, one or more receivers. So that's what we're able to do in the direct sampling world, and we call that a spectral capture unit. We capture the entire spectrum, and by the way, you can look at the entire spectrum, and then you can slice it up into multiple receivers and transmitters. And all of that's done in the digital world. So that's what we set out to do a few years ago. So, in May of 2012, this is the crowd that we took to Dayton, and we showed off the Flex 6000, the 6500, and 6700 we announced in 2012. And that was the team, and that's the first units there showing there. A long way from that first little 10 by 10 booth, and they're standing right where that booth was. And so we came out with a series of the 6500, the 6700, and then a year later the 6300. And these are different tiers of radios that had different capabilities. The 6700 is like two 6500s in one box, meaning I can digitize two antennas at once. I can have a 6-meter antenna and a tri-bander, 20, 40. So I can be looking at all these bands at once. I can look at up to 8 bands at once. I can monitor propagation. I can be having digital decoders running on all those bands and looking for signals on all those bands. PSK31 on all those bands, or RIDI, and all those different things could be operating at the same time. So another thing we chose to do was use that Ethernet technology we developed on the government systems to make these radios servers. If you'll notice, this is a Cat5 cable plugged into here. That's a server. That thing's running Linux inside the box. And so this is a server, and all these other devices are clients. So that can be anywhere in the cloud. What are the implications of that? Well, this is actually my shack now that I've remodeled it, and I've got a desk here, and that's a 12U rack. That's a 6700. That's a rack-mounted PC there. That's automated antenna control and power supply. That's my station. I can roll it out, and I can use it anywhere in my house. I can actually set up my iPad so I can use it remotely. Because it's a server. It's in the cloud. I can have multiple radios that are in the cloud. So that means that if my shack is in the cloud, there are all kinds of possibilities that open up. What about a D-expedition in a box? You put all the radios in a box, have them all wired up, put the radios at the antennas, and all you have to do is run Wi-Fi to all the users. You don't have to run all the cables and powers to the user. It simplifies that. Contest station, same way. My station, I can take Maestro, which I'm going to show you in a few minutes, and just go anywhere in the house with it and operate, or my iPad. So it really opens up a lot of things, like the shack becomes as big as the network. The station automation over time becomes integrated. So if you're going to be remote, you need to have all your antennas and your rotors and all that kind of stuff be able to work remotely. So it drives station integration. And it opens up many user interface options. You don't have to be tied to the shack. and you can operate anywhere. Those are some of the implications. The prerequisites are you have to have Ethernet data communications. You have to have massive signal processing in the radio. Technically, what's in that little box right there would be the equivalent of a Cray computer in the early, around 2001 or so, a Cray computer. That we couldn't have afforded that. But so many things have driven that cost down that we can now afford it. To put that in a ham radio. By the way, I did the consumer price index on a Hot Water 101. Anybody remember that? It was $400. Today, that would cost $2,500. That a hot water kit. That's the same price of that with a Cray computer in it. That box with a Cray computer effectively in it that directly digitizes the signals. The same, but this one's already assembled, and you had to assemble the Hot Water 101. So that gives you a kind of where things have come and the capability of bringing that kind of processing down to where we can afford it. We needed a thin client design. In other words, the processing is done there, not in here. Need to be able to do that because we've got to run the data across the network, and so we need to keep the bandwidth low enough. And we needed to have a programming interface that would allow us to have many different kinds of clients. In fact, we opened our programming interface and we have over 100 developers doing code for our radios now. Not just, and there are commercial developers as well. Homeland Security's developed software for it. There are two 6700Rs going on to the International Space Station next year to track ships using AIS technology, which is kind of like packet radio for ships. So they're going to track them around the globe. It's a VHF system. So if you have these client servers, then we can have multiple types of interfaces. Well, one of the drawbacks that some people have raised with us is they didn't like just having the PC interface. Now, some people love it, having the PC, because we can have large screens, but some people wanted knobs. Just as simple as that. They wanted knobs. Contesters really have a reason to do that. It's all about workflow. And so we listened to that and we said, we don't want to just build another box knob radio. We really want something that has unique attributes to it, and that became Maestro, which is essentially a remotable smart SDR client with knobs and buttons on it, but it can be used in place of the computer. You don't have to have a computer. This becomes a user interface, and it's optimized so that you have just the controls you need on a regular basis. We didn't try to put 100 knobs and buttons. I've used some of those radios, and you need the manual every time if you walk away from it for a day. And if you're in a dark room, it's scary. You can never find which control to operate. So we wanted just the ones you use all the time, and then we didn't want to have multi-tiered menus that you had to learn how to go through. We wanted everything easily accessible. In fact, I can demo how to use the radio in 30 seconds. Everything you need to know how to operate the radio, I can do in 30 seconds, and I'll do that in a little bit. So we decided we wanted to interview some people and find out. So I went to what it needed to do. I went to Silicon Valley and interviewed a bunch of contesters and DXers because they're the ones that really use it heavily. And so I interviewed some guys out there, and then I went to, anybody know K9CT? Ever heard his? He ran the Navassa Island DXpedition. He's one of the top contesters in the world, certainly in the United States. He's in Peoria, Illinois. Went up and spent a weekend with them while they were running the, I think it was ARRL contest, the Internet DX contest, and just immersed ourselves in watching how they operate and tried to study how do you get the most effective workflow in a radio? What's wrong with the existing systems that are out there? And then on the lower right is 403 Alpha, Ranko Boca. He's probably the top contester in Europe. He's in Montenegro. And so he was in our offices visiting us, and he said, you know, the only thing you don't have for contesting is you need some knobs. And so I said, well, would you sign a non-disclosure? And so he did, and I brought out a mock-up of what is now Maestro, and he jumped out of his chair and he said, "That's it." He said, that's it. That takes you from here to here. So I said, maybe we're onto something there. So we built Maestro. And so what we did was those K9C2E and 403A consulted with us on exactly what the knobs and buttons do. Now it turns out if it works for a contester, it'll work for anybody. It really will. And by the way, what they told us is don't make knobs do three things by pushing it too long, you know, because I'll end up getting it in some mode and I can't figure out what it's doing. Make it do one thing. Put plenty of room between the knobs. I got fat fingers. Don't make it so there are too many things there and I get all screwed up. So we learned a lot of things about that. They want to be able to know exactly what it does, and it needs to do the same thing every time, and I only want the controls that I use all the time. So every control there has a specific reason for being exactly where it is and doing exactly what it does. So this might be one of the first ergonomically designed user interfaces for a radio, rather than just how many knobs can we throw on it, or buttons can we throw on it. So this, instead of a little bitty pan adapter, we have an 8-inch touch high definition touchscreen pan adapter on it, and we can show 1 or 2 panophiles, and that means I can have it on 2 different bands. I could have the top one on 10 meters and the bottom one on 20 meters, you know, and be operating on both bands, which is something you do in contests, by the way. So it has an integrated CW keyer, mic, line in, line out, everything. In fact, hopefully if it's charged a little more, it'd be better for me to just pick it up and show it to you. So that's it. Can everybody see it? I think that battery is really... So you can see I've got an 8-inch diagonal HD touchscreen, and I can actually pan the pan adapter just by doing that, and zoom there.
It sure looks awful expensive.
And it has your knobs on it too. We'll let you all come up here. If I want a second pan adapter, I just touch right there, and now I have another pan adapter with another receiver here. And it's tuning the B knob down here, and it's touch as well. And so I have the A controls here, the B controls here. I can control audio, AGC threshold, the bandwidth of the filters, high cut, low cut of the filters for each of the 2. Here, if I want to change the mode and so forth, I just touched on the frequency. And there's the, I have the bandwidth of the filter, I have mode, the band, I can type in a frequency, and I can do that for the A VFO, and then I can come over here and do the B VFO. If I touch there, I can change my antennas. So I can touch there, I can touch here for all my transmitter controls. I just showed you everything you need to know. All of that is what controls the radio right there. So it has a battery that's going dead on me because I didn't charge it today. I'll show you that. That's a cell phone battery. You've seen the cell phone charger batteries? I got some more down here. I'll pull one out in a minute and put it in here. But it hooks up to a USB. You know, USB.
Apple battery that you can't replace.
No. Over here I have a Ethernet port, so I can go hardwire. By the way, I'm running Wi-Fi. You realize I can walk around the room with this radio. It's controlling this radio using that Linksys router right there, operating the radio by Wi-Fi. That's never been done before. So what that means is I can have this in the shack, I can grab it, go to the living room, and chase DX, or out by the pool. So that's a different way of thinking about operating a radio.
Just don't throw it.
Yeah. It weighs under 4 pounds with the battery, a little less without the battery. The battery charges in circuit. It has microphone, line in, push-to-talk, phones, line out, power speaker, key. It's got a K1EL keyer built into it too. So basically it's everything you need for a radio, to operate a radio. And usually if I had charged it and I had the larger battery, about 6 hours. Something like that. So when I take a break here, I'll plug in hopefully I've got a more charged battery over here. You want to plug it back in over there for me? I thought I had charged it, but I guess I forgot. So this is we announced this in May, and have been taking pre-orders on it. We're expecting to start shipping later this month, in December, in the next few weeks, start shipping this device. So, and by the way, it's today you can use it anywhere inside your home LAN. We'll be adding software by Dayton of next year that'll let you take it anywhere on the road. We've actually used it in a test mode over a virtual private network. We were in California operating a station in Arizona in the restaurant at Pacificon, which is the ham radio convention out there. So we were sitting there at dinner, listening to his radio and tuning it in Arizona. That's pretty cool when you think about it.
Pretty cool that a mobile phone unit like that.
Yeah. Yeah, and it was amazingly responsive. Amazingly responsive. Now, don't let me forget to show you something on my iPad. I have to show you that after I get here. So let me talk about a few other things, and then we'll get to demo time here. So, because this is a software-defined radio, we can keep adding things to it. So, back in September, we came out with our version 1.5, and we added this dongle which has D-Star on it. You plug it into the USB port on the back of the radio, and you load the waveform in the software, and it pops up as a new mode. We had previously done that with FreeDV. I don't know if you've heard of FreeDV. It's another digital mode that's an open source. It's called Codec 2 FreeDV, so it's a digital mode. The module actually has Fusion on it, but we haven't enabled it yet. So we're kind of waiting to see if there's demand for it to add Fusion. But that gives you HF, and on the 6700 you can run on 2 meters with D-Star. And so apparently some of the D-Star nets have really perked up in terms of the number of customers, people that are operating it. Were you going to?
So if you got a D-Star radio already, you don't need this particular chip, is that correct?
No, it's just an option, a little dongle that you can plug in that allows this to operate D-Star.
Okay, so would it have Fusion, you just haven't enabled it?
Right, it's on the chip. That dongle has like 100 different modes. And these
all over the place out here.
yeah. So, I'm sure we'll add it at some point. It'll just become a software upgrade to it. Yeah. So we added a new RIDI mode, D-Star mode. We added full duplex on all the radios, so you can simultaneously, if you got 2 antennas, you can be listening while you're transmitting, which is one of the things you do for satellite operation. It can be really useful for contesting, DXing, where you want to listen to if you've got enough isolation, you can listen to the DX station while you're transmitting. We added single operator 2 radio on one radio in the 6700, and I'll show you that in a second. We also added some new, this is a new wideband noise blanker. Look at the noise floor. You won't be able to hear it. We're going to turn it on in a second. Did you see that? Hear it? Turned it off. Turned it on. What we're able to do, because it's a software-defined radio and we're digitizing the antenna, we look at the entire spectrum and we can identify the impulse and basically subtract it. much more linearly than you do with the traditional kinds of noise blankers. So that's some of the magic that we can do in signal processing that we weren't able to do with the traditional radios. Yeah. It eliminates most of that, but we allow you enough adjustment range that you can make it aggressive enough that it will interact. In other words, you have to adjust it properly, but we needed to leave enough range so that when the bands are not as crowded, but the noise is lower, you have more aggressive adjustments. So there's always a trade-off between those two. One thing to remember is there's no such thing as a silver bullet that addresses all kinds of noise. People don't understand the difference between impulse noise and non-correlated and correlated noise. That's an area of education that we need to do, because everybody thinks, well, my noise blanker doesn't lower my 40-meter noise floor. Well, no, it's not, because 40 meters is noisy. That's propagated noise. You can't get rid of that. So there's the things like that we need to do a better job of educating.
Noise is like, in my house, I have a plasma TV that generates just
Oh, gosh.
a nightmare noise when I
Get rid of it.
That's
Sorry to say that.
marriage.
But the problem is those are real signals. What it's generating are real signals. And that's the hard thing about some kinds of things. Switching power supplies generated harmonics with real signals. Those are real signals. And we could get really technical about the difference in it, but if you get rid of real signals, you get rid of other real signals. That's kind of the problem with man-made noise of that type. But
Next thing a little Peter, I can tell if they need to tune over or not on the tune.
yeah, I didn't mean to be too flip there. Let me talk about it real quickly. Single operator 2 radio is a contesting mode where you're calling CQ on one band and you're search and pounce on the other band. And if you have reasonable isolation, that's the only way to win as a single operator. It really is, because the rates that you have to run. And so to do that, traditionally you had to have 2 radios and a bunch of boxes and baling wire and duct tape to make it all play together. Here's what the back of K9CT's station over the upper right, that's what it looked like, and that's what the front of the station looked like to do SO2R. The equipment there you see is like $12,000 to set that up, at least $12,000 set that up. Yep. K3 will cost you fully outfitted with a P3 about $6,000. It's about the cost of one station with all the filters and things like that. So here's his new station with one 6700 and a Maestro running SO2R. Virtually no wires. Everything is done in software. It's totally integrated with N1 MEM. You can, with the 1.6 software, you'll be able to CQ on the fly and it'll record it to the right wave file. It's all integrated with OTSRP and K1EL emulation. It automatically emulates the K1EL keyer. All of it's seamless, integrated. And he can operate one band on the top of Maestro and the other band on the bottom of Maestro. He was telling me he was operating the sweepstakes. And he said, this is the first time I've ever been able to see the holes that I could just click on the pan adapter with his finger and go there, and he was there rather than twiddling the knob. That was kind of an interesting comment about what he was able to do. So we're kind of trying to revolutionize contesting as well. Also, I mentioned that because this is a server, you can have different clients. Maestro is a client. The PC is a client. You can have a Mac client. We have the guy that wrote Mac Logger has written a user interface called Dogpart SDR that talks to our radio using our API. So you can run completely in the Mac environment now. And K6TU, let me kill this one so that I can bring up another client, because I don't have multi-client just yet. Do that, and I'm going to show you, hopefully, Okay, this is an app available on the Apple Store. It was written by a guy who is a venture capitalist in Silicon Valley. He's K6TU, he's a ham. And he ran Cisco's engineering organization one time. He invests in companies now. He's a ham. Low friend in high place said, I want to write a client for this radio. So he wrote this client. So this is the AM band here. So it's an iPad app, native app. I can pan, tune. So let's see. Yeah, let's see here. Yeah. It's pretty buzzy in here. Let's see. 620. Yeah, I was listening to... I'm getting it, but you got a lot of buzz on it in here. We could go up to, let's go to, yeah, you can watch it here. So let me go to, let's see, it's 40. Oh, look at the noise in here. I wonder if 80. What'd you say? Oh, yeah, and they're on nighttime power, aren't they? Is there another station that's closer that... You can see 80 meters. We've got lots of noise on 80 meters. I'm going to turn the lights. Can you get the lights here a little bit? Let me try.
I don't know about those on the side. Mike, you know if those are security.
Yeah. Yeah. Let's see.
The stuff that you're doing transition into commercial AM, FM radio sets?
In other words, are there other companies building them into commercial sets?
Yeah.
They're building those on a chip. There's a company in Austin called Silicon Labs that builds AM and FM on a single chip. They also build digital TVs on a single chip too. So that kind of technology has gone into a single chip for that kind of consumer electronics. I am not seeing many stations. Let's see here. Yes, you can. It's an in-app purchase for the transmitter version. The receiver is free, which is what I just downloaded this afternoon, but you can do an in-app purchase for that. So the receiver, you're talking about the radio there? Yeah, the receiver is actually a computer. The radio is very good with the antenna in here that we're having. I'll have to... There is a guy working on an Android version. Let's see, I hear some stations there. Let me go to... there is a Windows version, yeah. Smart SDR is the Windows version. A lot of people are running that on desktops today. Yeah, we're using under Linux, did you say? I don't know the answer to that. I think it does, but I'm not an expert on it. I'm distracted here trying to find some good signals on the band. What is there? I can see some. What you're seeing is switching power supplies. Look at that. You see, see that ripple? Those are switching power supplies. So I guess our vertical antenna is probably picking up a lot of those power supplies. But so we don't really have many good signals in here. But you get the idea of I'm running the radio over Wi-Fi. If you set it up, you can set up something called Soft Ether, which is a VPN, virtual private network. You can set that up at home, and you can run today with the iPad remotely. We were running that same Arizona station remotely using the iPad when we were at Pacificon. So that capability exists today with the iPad app. So there's several people working on different clients on different platforms. So I know for sure the Mac. I know a guy that is working on a Linux and a portable version. And I do know that there's a guy that has a Android app running. So I don't know the state of all that. And then there are other people working on various things. So those are independent people. Basically what we support is Maestro and Smart SDR. And Smart SDR runs on the PC environment. A lot of people are running them on the Windows. What does Microsoft call their tablet?
The Surface tablet.
Surface. Yeah, the Microsoft Surface. Their new tablets run it really well.
But there's a number of Dell and some others who are Windows 10, and they're maybe 2 gigs. I don't know what the minimum RAM is, but there are many out with 2 gigs of RAM.
Yeah, people are, because these are thin clients, they'll run on very low-end machines. I saw some people saying they were able to get it running on something they bought at Walmart for $100, $120. And there's a Chinese one that they were running. I'm not saying go out and just run out and get one, but you can run it with a single pan adapter on those kind of things, those kind of tablets. So.
I see on your website that there's another product that you got coming out in a little bit. About $500 or something like that.
You're thinking about the 1500, which is available right now.
Okay, that one's $500.
Yeah, that's like $550, something like that. So those are available now. That's a little brick size unit that plugs into USB and it runs Power SDR.
And then you get back to the for your microphone.
Yeah, you hook. It's got a USB port, mic, key, and.
I saw this when the internet goes down.
Well, this will still run when the internet's down. You don't have to have external, unless you're running remote. If you're running remote, then you're dependent on the internet. Inside your house.
Personal network, you're good.
Yeah, and I can actually plug that RJ45 into the back of Maestro and run it without a Wi-Fi. I literally plug it in the back of the radio. I don't even need a router to do that.
So just woods, if you don't have internet, that you can still get a hold of it?
Absolutely. Well, so if I were going to mount this in an RV, it's got 4 places here for a VESA adapter, VESA to RAM, so you can mount it in an RV. You put the radio back somewhere in the back of the RV or in the trunk or whatever, and you run just the blue cable from the Ethernet port back there, and that's your control cable for the radio. And so you have...
So you have a computer in the back of the RV.
Yeah, well, you don't need a computer with this. This replaces the computer. Does that make sense?
I'm just trying to see how, in case of emergencies, everything goes down, how it's going to work with.
Yeah. In fact, I'll hook it up that way in just a second. I want to see if I've got a charged battery here that I can run on it. Like I said, that's a cell phone battery we bought on Amazon. Yeah, let me show you. Yeah, that battery's charged, I think. It helps to have a full battery. So I can show you just a second how we would hook it up doing that. Let me get it started here. Hear the relays click? This was causing it to click.
You can also turn that off from that Maestro, can you not?
Currently, we don't have. We will have it so you can turn it off to do that. So I'll just walk around so you can see what it looks like. You there? Thank you.
You did a good job.
Thank you. So, do you want me to take a few more questions, or what?
Okay, let's
You want to see?
Yeah, let's. Guys, listen. Let's kind of rack in order, and I know all of you got questions for your side about this. So let's do for the sake of time. Let's do a few questions. And so, if you've got some questions for Gerald, I know Don, you've had some good questions, and I'm really surprised our resident engineering staff in the back there hadn't had some good questions. Mike,
First person that asks a question gets a hat.
there you go.
Is that with you? Okay. What is your question?
When I talked to you all the time when you were
Oh, you did, didn't you?
Okay.
There you go.
All right, Thomas Gandy. Thomas Gandy's got a question.
Gerald, what is the, so right now, the front end of the receivers, 6 meters through HF, and you buy the dongle, and it'll take you up to the 2 meters. Is there any plans to go?
That's not quite correct. Let me correct you before. So the 300 and 6500 go through 6 meters. Actually, 6500 goes through 4 meters. However, the only one that goes to 2 meters is the 6700. So I want to clarify that. The dongle gives you free DV, D-Star.
Okay, so it's just basically got the chips in it.
The modem,
You codec in there.
that's right.
Okay, one follow-up on
So
that.
you get one
I've
too.
got
I
one
promise I
follow-up,
won't do this.
Gerald.
Oops.
Gerald, one follow-up on that. You know, we've got, as per the recent ITU meeting, we've got a new band allocation. What are some of your thoughts about that? What
It's
would be
already on the unit. We've got, it's what, 630 meters and 2200 meters have buttons now on here.
Okay.
And it's low power. You can, it's out the transverter port. All 3 radios do it today. So you go listen on those bands. You can listen to submarines if you want to on DC, down at below 60 kilohertz.
All right, so that's one of the virtues of the architectures. These changes, many of them are implementable pretty easily. Okay, our gentleman from, I think, the Big Easy had raised his hand for a question. He's looking at his phone now. He's entertaining Tom Brown. Yeah.
Yeah.
We were looking online.
Okay, what was the question?
I was going to ask if on the Wi-Fi version, if right now you can't, you said, but will there be a time when if you're in a plane that's got Wi-Fi, like some of them do, you can, I know I've got a MacBook and I've used it on the plane.
So the question was, will you be able to run from a plane? There are people doing that today with tablets over VPN.
Yeah.
So the answer is yes. There are people doing it today. Now, we don't support it natively. They're using VPN, and they know how to set up a VPN. So that's happening today. In fact, that same guy. In fact, there's a guy who is running his Flex 6000 in California from the Mediterranean on a ship. And so, I mean, if you have a little bit of adventurism in you can go do it today. By next year, about May or June, we will have it so it's native out of the box. You'll be able to take a Maestro, turn it on, run your radio at home. That's the kind of plug and play.
And Gerald, as cars get internet built into them, it'll give a new meaning to a portable station, won't it?
Well, you could also do that today. I mean, with the iPad app, you could run today with your, if you've got LTE,
Right.
you've got a hotspot to LTE using the iPad app. You can do that today.
Okay.
Yes. Yeah.
Okay. All right, we got one here in the middle.
Said it has a CW.
Sorry. Yes.
Now, does that have the keyer in it, or is it straight key?
It has a K1EL keyer in it. The Maestro has a keyer in it. The radio has a keyer in it. You can go straight in. If you want to do QSK at 100 words a minute, you really need to plug into the radio. Because the radio does it all in hardware. But both of them have paddle input.
Okay. Now, Gerald, have you ever heard of Pope Gibson?
Pope Gibson?
Yeah, there's no R in Pope Gibson in Mississippi. We've got a gentleman here who's got a question.
Well, my question is, do you have a model that needs an idiot-to-idiot tester?
We have a few of those already.
Okay, we got another question here in the middle. Had his hand up a second ago. Go ahead.
Software defined, so I mean, to add new features, you basically just change the software.
Yeah.
How often do you come out with updates and add new features?
On average, 3 to 4 times a year, we do a significant release, what we call a point release, like 1.5, 1.6, 1.7, etc. So we're about to do, I think, our 4th release this year.
Let me compliment you on the documentation with the releases. It's very good.
Thank you.
It's like zero, it's a no-brainer. Okay, you don't have RTTY in it, so by requesting, you can add that very easily in software and just update.
In fact, people were the contesters were asking us for a true RTTY AFSK mode where you would click tune on the mark and it's dead on with the filter exactly where it needs to be and it's in the log with the right frequency. We created that. That was in 1.5. If you ever work RTTY, you'll know what I'm talking about. So now you can point and shoot like fish in a barrel on RTTY, and it's on the right. All the stuff is right in all the logger and all the stuff like that. So
This upgrade is going to be self-upgrading, like through the internet or something?
So the way it works is on the radio today, you go to our website and you get the latest version, you download it, you double click on it like any Windows application, it says your radio is going to upgrade, it gives you the bar and you can see the radio will flash saying it's upgraded. When it's through, it comes up, you're in that version. You can go backwards if you don't, you can go backwards, you can go forwards, you can keep multiple versions on your PC at the same time.
Okay, Tom Brown had his hand up here.
Give him a mug. I was out of hats. Yes, sir.
Who got the mic?
Noise rejection, every
yeah.
signal rejection, front end entirely in software, or are you switching any bandpass filters in hardware?
All the noise reduction is 100% software. Some of it's done in what we call a field programmable gate array, or FPGA, which is done in, it's programmable hardware, so it's done very, very fast. Things you can't do in a computer, you can do in a programmable hardware. Yeah. Give him, you already have a hat?
Oh, okay, we got one right here in the back. We'll come back up to Arnie in just a second. Yep.
I'm going to ask that dumb question. Because I've never seen one of these. I know absolutely nothing about it.
Let me slide by here.
If you don't have the Maestro and you have the radio, do you control that from your PC? Do you have something on your screen?
Yes.
Looking at change frequencies and all that?
Yes, you do. In fact, I might just want to go back to show you I have a picture of what the PC version looks like. Let's see if I can find it here. Usually I like to show it on a large screen too, but all right. So you see right here, that's Smart SDR with a single pan adapter open. This pen adapter, you can zoom out to 14 megahertz. You can have multiple pen adapters. The 6300 can have two, so you can have, it goes 7 megahertz, so the 6500, 6700 go up to 14. So you can see all of HF. You can put two side by side and see from basically 160 through 10 meters all in one swath. And you can actually watch the ionosonders sweeping up the band, and you can see where the MUF is. You can see which bands are open. You can zoom in to the point where you can actually see below the noise floor. You can see signals you cannot hear. In fact, I don't know if I said this in here, but one of our customers said that he was chasing Iran here recently. I think they're on the air, right? That sound right? I think it's Iran. It was some hard-to-get country in the last few weeks, and he could hear the DX station, but he could not hear who he was talking to. And that's kind of a problem when you're not a big gun and you want to go work this guy. Well, he was able to, you can scroll back on the waterfall. I can take my finger and I can scroll back and I can see the Zulu time, and you can actually go back and see who he worked. You can see exactly the frequency he worked and who he worked last. And he was able to drop his, even though he couldn't hear him, he was below the noise, he could see him, he dropped his transmitter there, worked him on the second call. Just by, it's kind of shooting fish in the barrel.
All right, let's go one more question. Who's got the final question?
Who got the, you got?
No, Arnie had his hand up.
Yeah, I have a Flex 3000 and I do digital modes, and you have these Russian virtual audio cables.
Yeah.
Is that eliminated in the smartest?
So we've integrated all that into our software. We call it Digital Audio Exchange. It's automatically installed and set up. And so it has some similarities, but you don't have to go buy any third-party software. It's all there. So you can take a receiver and assign it to a digital channel, and I could have you can bring up more than one FL Digi, for example, and you can be on different frequencies with FL Digi monitoring, or you can have RIDI and PSK31 on at the same time, and all of that's integrated. It's automatically loaded, and the CAT software and the digital mode software those are clients, so they could be running on a different PC. You could have a PC running the digital mode software. It talks directly to the radio. It doesn't go through the client. And so Maestro could be sitting here controlling the radio, or I could be running it from the iPad, and the digital stuff could be running on a different computer. That really is a tremendous capability of the architecture.
Okay, was that the last mug, or
I have. Did somebody not get a mug back there that asked a question?
There was another question. Yes, the gentleman right here had a question.
The Maestro front end, will it work with all the different flex radios, or is it just one flex radio?
It works with all of the 6000 series.
Okay.
And the same thing true for all these clients, the Mac client and so forth, work with the 6000 series. They don't work with the earlier radios because the earlier radios were not servers.
Given that, you have more than one Maestro if you have like a 6700.
Today, no, but we're planning to. We're committed to it because the contesters want to run multiple clients.
K3LR.
Yeah, K9CT wants to, what he basically wants to do, he runs called multi-2, where you have two operators, each operating on one band each, respectively, like 40 and 20. And they want to use one 6500 with two Maestros at each station. So 2 radios gives you 4 operators. That's what they want to do.
All right, the final mug. The final mug. All right, who wants the final mug? All right, Rusty.
What kind of bandwidth does this require over to go remote?
Okay, Maestro with 2 pan adapters running takes, and at full speed, 30 frames a second. That's really, you don't need to run it that fast. It's taking 2.5 megabits. per second. I can slow it down to where it's kilobits per second. And we haven't actually optimized it yet for remote. We've optimized the audio, but not yet the video. So we'll be doing more optimization on that. So you can run it on very low-speed networks if you're okay with slowing down the pan adapter a little bit.
Well, I got that covered. I've got 2.5
Oh, you don't have a problem then.
Okay, that's our last mug. Listen, let's show our he's come here on his own nickel, visiting family, stayed over, and we all know with our kind of XYLs and things, I said, hey, point out the after Thanksgiving sales at Renaissance as a negotiation point. But he also has some literature here. Let's give him a CMSARA welcome and thank you.
Thank you. And I have Maestro buttons. Everybody can have a button.
Okay, now.
There'll be a collector's item.
Now, we know, I lived in like Pope Gibson, it's called Fort Worth. All the good guys in Texas wear white hats. So, Gerald, we want you to have one of our white hats for Central Mississippi Amateur Radio Association. It'll adjust in the back. And because you live on computers, we'd like you to have the opportunity to use a mouse pad.
Thank you.
For us. Our board of directors has begun a little new endeavor. And one of the things that maybe we hams don't do as much of as we should, witness our friend and colleague George Thomas winning the Dayton Hamvention Award a couple of years ago, and some of us got together and did a little private dinner for him. You know, those are things we need to do, and we need to honor one another when we do things that are worthy. Our informal slogan, but do things and achieve things. You know, we ought to take note. Now, you know, being a former college professor, I got to give you a little history lesson. The etymology, not entomology of bugs, but the etymology of words. The term high cotton originates from the rural farming community in the pre-Civil War, when high cotton meant that crops were good and the prices were too. The term has been generalized to mean one that's doing well or successful. So the board of directors has authorized a periodic high cotton award by the Central Mississippi Amateur Radio Association. And it's my real honor to introduce that award. And our first award will go to our speaker tonight, Gerald Youngblood. Gerald, if you'd come up, I'm going to turn it over to our president. Got to get some pictures.
This is our inaugural run here.
There you go.
That is truly clever.
You want to know why? You want to know why you get this? Because you do stuff.
Thank you so much.
CMSARA. We do stuff.